The first real images of Mercury. We've all thought at some point about the secrets of our solar system. After all, if the 8 planets circle within a very limited amount of the solar system, what happens in the remainder of the volume we call home? We learn more about where we came from and how the planets formed as we send more robots into space, increase our observational capabilities, and begin to experience space for ourselves. Even with our expanding knowledge, we would be stupid to believe we had all the answers. So much remains to be discovered. The planets are an excellent example of how scientists gradually gather fresh data and draw new conclusions. A lot is learned about the planets with each new space mission. With fresh knowledge, the discovery of more satellites orbiting a planet with a changing atmosphere can be amended. We don't know everything there is to know about the planets, so let's look at the first true photographs of Mercury that we've obtained after decades of research and effort. Mercury was a world of mystery in the early 1970s. Because of Mercury's small size and close proximity to the Sun, Earthbound astronomers could only draw imprecise black markings on their maps and conjecture on what they really meant. Meanwhile, optical, radar and infrared investigations from ground and balloon discovered no sign of an atmosphere. This implied that Mercury's sun-baked surface would maintain a record of the solar system's early events, free from the erosive effect of water, wind or ice. The only way to confirm the notion was to send a spacecraft to the intriguing little world. However, it was not as simple as it sounded. Although Mercury can approach Earth at a distance of around 77 million kilometers, it takes a lot of energy to break a spacecraft into a transfer orbit that meets the innermost planet. The most energy efficient way to reach Mercury is to use Venus's gravitational pull. Studies undertaken in the 50s and 60s revealed that such gravity aids might be utilized to adjust a spacecraft's trajectory without the usage of rocket fuel. With a few small orbital adjustments, the craft could return to Mercury's orbit at precisely the moments when the planet was in that spot. The main disadvantage was that the surface lighting would be the same for each encounter. On the 3rd of November 1973, the Mariner Venus-Mercury mission, afterwards dubbed Mariner 10, took out from Cape Canaveral, Florida. It was the first spacecraft to harness the gravitational attraction of one planet to reach another. The unprecedented gravity assists by Venus occurred on February 5, 1974, when Mariner 10 flew by a distance of 5,768 kilometers. The spacecraft trajectory and speed were altered as a result of the close approach, putting it on course for a collision with Mercury. Mercury appeared as a broad crescent in the initial hazy photos returned on March 24, 1974, from a distance of 5.4 million kilometers. As the range narrowed, it became evident that the planet did in fact have a highly cratered surface, similar to the ancient lunar highlands. Although the closest approach occurred on the planet night side on March 29, 1974, at a distance of 703 kilometers, Mariner 10 was able to transmit back photos of a distinct sunny hemisphere on the outward leg. Scientists were surprised when plasma and particle data revealed the presence of a significant magnetic dipole field akin to Earth's. An internal dynamo housed with a fluid inner core generates such a magnetic field according to theory. Mercury is so tiny that the planet's liquid iron core was believed to have cooled and hardened billions of years ago. On September 21, 1974, the spacecraft followed a trajectory that allowed it to photograph the southern hemisphere. The second flyover took undertaken on the sunlit side at an altitude of 48,069 kilometers in order to scan the complete hemisphere, thus connecting the two regions seen during the first encounter. Despite the low spatial resolution of 1 to 3 kilometers, the 360 photos extended coverage of the lighted hemisphere from around 50 to 75%. On March 16, 1975, the third flyby focused primarily on magnetic and particle observations in an effort to better understanding of the planet's magnetosphere and its interaction with the solar wind. Mariner 10 sailed over the surface at a height of only 327 kilometers during this final encounter. A glitch with the ground station in Canberra, Australia meant that only 1/4 of each high resolution image could be obtained. Mariner 10 was grounded on March 24, 1975, after its onboard fuel supply ran out. Moreover, 2,300 black and white photographs of Mercury were obtained in total, many at moderate resolutions, but just a few at 140m in total. 45% of the Earth was photographed. The surface was seen to be divided into intercrater plains, smooth plains and deeply cratered terrain, similar to that of Earth's moon. The most noteworthy individual feature, which was partially visible on the morning terminator, was a massive impact basin known as calories. Mariner 10's ultraviolet observations revealed an extremely thin atmosphere. The surface pressure is a fraction of picobar, or 1/1,000,000th of the Earth's sea level's air pressure. For 3 decades, Mariner 10 was the only spacecraft to visit Mercury, and practically all of our understanding of the planet was based on the limited observations obtained during its 3 flybys in 1974 to 75. NASA decided to construct the MESSENGER, abbreviated as ME, Mercury Surface Space Environment Geochemistry and Ranging mission, to complete the survey of its cratered surface and conduct the first in-depth analysis of this small world. MESSENGER was launched on August 3, 2004 and arrived in a near-polar orbit on March 18, 2011. MESSENGER got gravitational aids from Earth, Venus and Mercury itself before entering orbit around the planet after a 7.9 billion kilometer voyage that comprised 15 rounds of the Sun. Prior to the orbit insertion maneuver, Mercury flybys in January 08, October 08 and September 09 allowed the spacecraft to match the planet's speed. During these contacts, the spacecraft mapped nearly the whole planet and collected important data for planning the nominal year-long orbit phase, which is equivalent to 4 Mercury years or 2 Mercury solar days. MESSENGER was equipped with 7 instruments to study the planet's surface, atmosphere and near-space environment. Scientists were able to examine nearly the entire planet in stereo using the multispectral imaging technique in order to assess topographic changes and landforms. Mercury's landforms and surface topography were mapped with a laser altimeter. The altimeter data and meticulous tracking of MESSENGER's trajectory aided in determining the thickness and structure of the crust, as well as mapping the planet's gravitational field. Other devices investigated Mercury's magnetic field and the makeup of its hazy atmosphere. The mission of MESSENGER was prolonged until it ran out of propellant and crashed into the planet on April 30th, 2015. By that time, it was evident that the volcanic activity had resurfaced vast portions of the world. The most notable feature was a large region of volcanic plains in the far north. Other surprises awaited. Mercury's magnetic field was discovered to be 484 kilometers north of the planet's spin axis, or nearly 20% of its radius, because the interior magnetic field is 100 times weaker than that of the Earth's. It offers minimal protection from solar wind. Mercury was discovered to have minimal levels of iron on its surface despite its high density and putative iron core, but very substantial abundances of volatile elements such as sulfur, sodium and chlorine. With all of this knowledge, a new period of universal discoveries will begin, and many more cosmic mysteries will be revealed, changing the trajectory of human history forever, so stay tuned.